my name is Tommy, and today we're talking about reaction rate. If X is disappearing at 5.0 times 10 to the negative second molarity per second, how fast is Y disappearing and Z appearing? So, with reaction rate, all we need to do is use mole ratio to determine the rates of the other two species. So, if we know that X is disappearing at 5.0 times 10 to the negative second molarity per second, all you have to do is multiply by molar ratio. So 3y per 2x, and as you can see, we get 7.5 times 10 to the negative second molarity per second y. And then we can do the same for z, where we do 5.0 times 10 to the negative second molarity per second times 1z per 2x, and we get 2.5 times 10 to the negative second molarity per second z. So we have the rate of disappearance of y and the rate of appearance of x. For this problem, we have to see what would make a reaction between a chunk of alkali metal and water happen faster if it is submerged. So we can either A, break up the metal, B, cool down the water, C, add more water, or D, remove water. So when we are looking at something like this and we're considering how to make a reaction faster, we have to use something called collision theory, which basically says if more collisions occur, then the reaction will happen faster. So let's look at it from that perspective. If we break up the metal, the surface area will increase, and therefore there's more area for the water to interact with the alkali metal with. So yes, collisions would increase. So let's look at the other answers. Cooling down the water. So that'll make everything slow down a bit. So collisions will not happen as frequently. So things will slow down, less collisions. So C, adding more water. If it's already submerged, then it's already completely surrounded by water. Adding more water will not do anything because you're literally it's like if you take a tennis ball and you put it in the water, it's like if you bring it lower into the water, it's not really changing how much water is surrounding its immediate surroundings. It's still the same, no matter how deep you bring it. Removing water would have the opposite effect, or well, maybe not the opposite effect, but it would still have less water interacting with area in the alkali metal in question, so that would slow down the reaction. So our answer is A, breaking up the metal, because it allowed us to increase our surface area. Some other ways you could have done it would have been to warm up the water, because then the average kinetic energy speeds up and you'd have more collisions. If you also put in a catalyst that allowed the reaction to take place quicker, that would increase reaction rate. Adding more alkali metal would increase reaction rate, and that's about it.